So now we learned about how activation gradients play a role in model learning. Before we get to understanding gradient vanishment and explosion, let's look at some simple intuition behind why this uh, why this gradient play an important role, how gradients help in model learning, and why a small gradient or a large gradient can affect our model learning. So suppose I am plotting my loss function against my model parameter theta. Suppose the loss function is convex. I'm taking very simple cases for illustration. Say it's a simple convex loss function, a convex loss function, meaning it has a shape like this. It does not have local minimas. So in this loss function, we want to get to here, its lowest point. And lowest point is, suppose at theta star, meaning theta star is my global solution, my best solution, optimal solution. When we do the learning, I'm going to use another color here. During any learning iteration, suppose I am here, say this is my theta n. From here, this gradient, which gradient is essentially the slope on at this point. Gradient means the slope. And when I get this gradient at this value of theta, I'm finding the slope at this point. Now, the role of the gradient is to drive theta n close to my global solution theta star. If my gradient is stable, what will happen is, from here, I will go to here, theta n plus 1, using this expression. The gradient is going to drive me here. And since the gradient is stable, I am likely to go from here to here. Next step, theta n plus 2, and finally from here to here. So at n plus c, I have reached my global solution. But consider another situation of large gradient that leads to an issue or is caused by an issue called as gradient explosion. This what happens if I have same loss function and this is my theta star. I wanna come here. This is loss, this is theta, and started here with theta n. When my gradient becomes large or is exploding, this gradient value, this nabla theta that I'm gonna compute is gonna be extremely large. And instead of driving me close to theta star, where I wanted to go, this gradient is taking me to another world. And from here it will be somewhere even farther, and I will go farther and farther away from my global optimum. It gets very hard to get to here. And that's the problem with large gradients or when gradient has exploded. In another scenario, when I have small gradient, which is vanishing gradient issue. Same loss, theta. I want to get to this theta star. Start with here, theta n. Now, when the gradient is small, in the next step, I reach only here. From here, next step, I reach only here. Here still I'm making some movement because I cannot draw a line which is of length 0. But in reality, it is almost a movement of 0, which means practically I will never reach here. And that is the issue with small gradient or when the gradients vanish.